Hi, I'm Josh McGrath, Soil Extension Specialist at the University of Kentucky in Lexington. In this presentation, we're going to talk about defining soil fertility. So Haviland, in his textbook, defines essential nutrients as those that are directly involved in the nutrition of the plant or metabolic processes. A deficiency of that nutrient would make it impossible for the plant to complete its life cycle, and also a deficiency is specific to that element. So adding another element will not correct the problems that we see with that deficiency. So when we talk about what essential elements are, we break them down into two broad categories. That's the macronutrients and the micronutrients. The macronutrients are those that are needed in the largest amount by the plant, especially relative to soil supply. We'll split that up into the primary macros and the secondary macros. So the primary macros are going to be nitrogen, phosphorus, and potassium. Interestingly, phosphorus is found in plant tissue at concentrations very low for the macronutrients. It's the lowest of all the macronutrients, tied right there with sulfur. But those primary macronutrients are the ones that we have to worry about the most, because a typical agricultural soil can't provide those nutrients in a large enough quantity to support plant growth. So we come in and we fertilize nitrogen, phosphorus, and potassium. The secondary macronutrients, again, are required in large amounts by the plant, but calcium, magnesium, and sulfur are typically provided by the soil. So while they're required in large amounts, soils have enough, typically in a form available to the crops, and so we don't have to worry about fertilizing those. The second category are the micronutrients. As the name implies, we need a very small amount of the micronutrients to support plant growth. And so the concentration of micronutrients in plant tissue are very small, and they're also typically very low concentrations in most soils. Now, the trick with these micronutrients is managing the soil environment and pH so that they're available. Again, we don't often have to worry about fertilizing for the micronutrients. And so those micronutrients, some of the ones that we might be worried about: boron, manganese, zinc, once in a while molybdenum. These are the ones that we worry about the most. Some of the other ones like copper, we're rarely going to see a situation where we need to fertilize these. But overall, if we manage the soil environment, most soils should be able to supply the micronutrients in adequate quantities to support plant growth. So it's useful to have terms to describe plant nutrient status. And so this figure here shows on the horizontal axis the nutrient concentration in tissue, and on the vertical axis some sort of relative measure of plant performance. So typically yield. So we can look at this curve as concentration of that nutrient in plant tissue versus the yield expressed by those plants. And there might be other kind of indicators of plant performance besides yield, but for this example we'll just talk about yield. And so there's a couple components. First is there's the deficient component of the curve. And so we see that performance increases as nutrient concentration in the tissue increases. So that's the definition of a deficiency. A deficiency is when adding the nutrient improves plant performance. And then we hit this range where adding more nutrient doesn't improve plant performance. We're kind of maximized in our yield. And so that's sufficiency, and that's what we're shooting for. We want a plant that is sufficient in any of those essential elements. And then we have this region down here where we might have negative effects of adding more of that nutrient. So that nutrient becomes elevated in the tissue to a concentration that causes negative impacts. Generally, this is most concerning with some things like the micronutrients. We can see toxicity from elevated concentrations in tissue. And then this is the point that we're really interested in, that break point between deficiency and sufficiency. That's the critical concentration. Really, it's a range. It's kind of a region in that tissue concentration that defines a plant being sufficient or deficient. And we want to be above this critical range in tissue concentration. So when we talk about soil fertility, one of the basic premises is Liebig's law of the minimum. Now, Justus von Liebig was a soil chemist in Germany. And actually, he didn't really come up with his law of the minimum. Carl Sprengel is the one that first defined this for plants. But Liebig was, I guess, better at self-promotion, and so this rule was named after him. But basically, it's we usually teach this using Liebig's barrel that you see here. And so a barrel has staves, and if we think about those staves as the essential elements, they're all required. And yield or production is limited by the required element available in the lowest amount relative to plant need. So the plant needs different amounts of NPK, the big primary macronutrients, and it needs very little of the micronutrients like boron or manganese or zinc. But they all, relatively speaking, have a sufficiency level that we need to maintain. And if any one of those nutrients is present in an amount lower than that sufficiency rate, then that's what's limiting our production. And so it's like that stave in the barrel, and that's where we're losing our yield potential. The water in this instance is the yield potential. And so we need to make sure each one of these essential elements is available in the amount required to maximize plant performance. And in this figure, I kind of added another component where I put pH in as that band around the barrel, because that's what holds everything together. And so maintaining soil pH at the proper level allows the plant to access the nutrients that it needs. So one important concept with soil fertility, though, is there's an old saying that says a productive soil is always fertile, but a fertile soil isn't always productive. What does that mean? Well, there are other factors that influence total plant potential and yield and growth. And so things like soil structure, soil compaction, moisture, pest pressure, weed pressure, all of these things, sunlight, light interception, they influence total yield and also influence the amount of nutrient needed by the crop. And so we can add all the fertilizer in the world to a soil that's not productive, and we won't reach our max yield potential. And so we need to manage the growing environment so that the plant has access to those nutrients and make that a fertile and productive system. So in summary, essential mineral elements are those that are required by a plant to complete the life cycle and maximize yield potential. Typically, we break these up into the macronutrients and the micronutrients, and we really only have to worry about the primary macronutrients as far as fertilizer goes. And then for the other ones, we just need to be maintaining soil pH at an adequate level and look for deficiencies that we may need to correct. For a soil to be productive, we need to think about all the other factors that control plant access to nutrients. So fertility is not the only thing.